Hello everyone, welcome to VLSIFlow. This video is a part of the complete Verilog HDL course where we learn Verilog from the basics and gradually move towards RTL design and interview level content. In this video, we are starting one of the most fundamental topics in Verilog, data types. Understanding data types is extremely important because wrong data type selection leads to a wrong hardware modeling. So before writing complex RTL code, we must clearly understand which data type use and why. Let me first explain what we are going to cover in this session. We will begin with nets, where we mainly focus on the wide data type. After that, we will move to registers or variables such as reg, integer, real, time, and string. Each data type a different purpose in Verilog. By the end of this video, you will clearly understand which data types are synthesizable, which are simulation only, and how they are used in RTL projects. So let's start with nets, and the most commonly used net in Verilog is wire. A wire is represent a physical connection similar to metal wire in real hardware. Very importantly, a wire cannot store any value. So instead it continuously reflects the values driven by the logic connected to it. Here we have to see a continuous assignment in Verilog when we use a continuous assignment using the assign keyword. The left hand side must be always a wire. This is because continuous assignments describe combinational logic, not storage. Whenever the input changes, the output updates immediately. So in the diagram shown, signals like wire 1, wire 2 and wire 3 are internal connections between logic blocks. These signals do not store values. They only pass values from one block to another. Therefore, such internal signals must be declared as wire. Now, let's talk about variables. Starting with reg. Unlike wire, a reg once assigned, it holds that value until it's updated again. The default value of reg is x, meaning unknown. So, procedural blocks. Any assignment inside procedural blocks such as initial and always must use a reg. This is because procedural blocks describe behavior over time, not continuous connections. Let's talk about sequential logics. When we model flip-flops or registers, we always use reg. In clock logic, the value updates only clock edge and remains stored between edges. This storage behavior cannot be modeled using wire. Next is the integer data type. An integer in Verilog is a 32-bit signed variable. It is mainly used for the loop counters, indexing and iteration, especially in test benches. So we can see here code. In this example, the integer variable I is used inside a for loop. This is the most common and correct uses of integer. In synthesis, we are usually avoid using integers for hardware storage, but they are very useful for control logic and test bench code. Now let's discuss the real data type. Real is used to represent fractional values such as decimal numbers. It supports both decimal notation and scientific notation. One important note is, a very important thing to remember is that real, it is not synthesizable. This means it cannot be implemented in hardware. It is mainly used in simulation for modeling analog behavior, delays or mathematical calculations. A time data type is used to store simulation time values. It is an unsigned variable and it is sized at least 64 bits. The default value of time variable is x. The time system function returns the current simulation time. We often use time and $time in test benches to measure delays and analyze timing behavior. Finally, we have a string data type. A string represents a sequence of characters enclosed in double quotes. Each character occupies 8 bits. Based on ASIC encoding, strings are mainly used in test benches for displaying messages and debugging and logging. They are not meant for hardware implementation. That brings us to the end of the Verilog data types. We have clearly understand the difference between wire, reg and other variable types. In the next video, we will learn vectors in Verilog, which are very important for buses and multiple bit signals. Thank you for watching. Please like and share and subscribe to VLSIFlow. See you the next video.